What's up, my dear students? It's Naresh Babu. Welcome back to Physics Crash. The Marks Gainer 2020 Marchakka Mark. Students, in this session, I'm going to discuss about JEE Mains 2021 questions from Dual Nature of Radiation. Let us start the game. Dual Nature of Radiation. JEE Mains 2021. Here the first question. An electron having Debroglie wavelength lambda is incident on a target in a X-ray tube. Cutoff wavelength of emitted X-ray is. So we have to calculate cutoff wavelength of emitted X-ray. Here the options. Option A 0. Option B 2m square c square lambda square by h square. Option C 2mc lambda square by h. And option D hc by mc. Solution. From Debroglie wavelength, we have lambda is equal to h by root 2me. It is equation 1. Energy of emitted X-ray, that is E is equal to hc by lambda suffix c. It is equation 2. Substitute 2 in 1. That implies lambda is equal to h by root over 2m hc by lambda suffix c. So if you do simplification here, you will get cutoff wavelength of X-ray, that is lambda c is equal to 2mc lambda square by h. So we got cutoff wavelength, that is lambda suffix c is equal to 2mc lambda square by h. So from the given options, option C is the answer. Now we will go with second question. An electron of mass me and a proton of mass mp are accelerated through the same potential difference. The ratio of the Debroglie wavelength associated with the electron to that with the proton is. Here the options. Option A mass of proton by mass of electron. Option B 1. Option C root over mass of proton by mass of electron. Option D mass of electron by mass of proton. Solution. From Debroglie wavelength, we have lambda is equal to h by root over 2m ke. Ke means kinetic energy. So now in the place of kinetic energy, I wrote electron volt, that is E into delta V, where E means charge of electron or proton and delta V means potential difference. So in this equation, H is constant, E charge is constant and potential difference also constant. So we can write from above equation, we can say lambda inversely proportional to root over m, because here h is constant and charge of electron and proton E is constant, and given the potential difference is constant. So we can write lambda is inversely proportional to root over m. So from this we can write wavelength of electron by wavelength of proton is equal to root over mass of proton by mass of electron. So from the given options, option C is the answer. Now third question. What should be the order of arrangement of Debroglie wavelength of electron lambda e an alpha particle lambda alpha and proton lambda p, given that all have the same kinetic energy. Here the options: option A, wavelength of electron is equal to wavelength of proton is equal to wavelength of alpha, and option B, wavelength of electron less than wavelength of proton less than wavelength of alpha. Option C, wavelength of electron greater than wavelength of proton greater than wavelength of alpha, and option D, wavelength of electron is equal to wavelength of proton, that is wavelength of proton greater than wavelength of alpha. Solution: from Debroglie wavelength, we have lambda is equal to h by root over 2m kinetic energy. From above equation, here we can write lambda is inversely proportional to root over m. Here kinetic energy is constant. In the given problem, they have given same kinetic energy. So we can write lambda is inversely proportional to root over m. So we know that mass of alpha particle is greater than mass of proton, and mass of proton is greater than mass of electron. So from this we can write wavelength of electron greater than wavelength of proton, and wavelength of proton is greater than wavelength of alpha. Why? Because here we got the relation, that is lambda is inversely proportional to root over m. So here which is having less mass, that one having more wavelength. So we got wavelength of electron greater than wavelength of proton, and wavelength of proton greater than wavelength of alpha particle. So from the given options, option C is the answer. That's about today's session, my dear students. I hope you like this session. If you like it, share it and subscribe it, and have fun. Bye students.